Hey guys, as promised, here is another example of what I'm calling a period change, because that's what this 3x does on the graph. It changes the width of the graph. In this case, it shrinks it. And then a question that popped up in a couple classes yesterday was, what if I don't want all the solutions? What if I just want from 0 to 2 pi? Do I still need to do the smiley face thing? And the short answer is you don't have to do it that way, but you need to do something to address the fact that because of this period change, you're going to end up with 3 times as many discontinuities as you might otherwise have on that interval. And I'll mention a couple ways to deal with that, but to me, through experience doing it and teaching it, the smiley face trick still works here. We just do one extra thing at the end. And so we will focus on the calculus here, focusing on continuity. But in order to do that, we're going to have to do some of that pre-calculus trig stuff. So for continuity, we start by figuring out just where something goes wrong. And so we've seen where things can go wrong with piecewise functions and various other things. But in most cases, we're just looking, okay, where is the denominator 0? So if I don't see a denominator, well, I'm going to make one. So we know, or should know, that secant of 3x is the reciprocal of cosine of 3x. And so our job to figure out where something goes wrong is to figure out where that denominator equals 0. Those are going to give me my discontinuities, and then we'll figure out whether they are removable or not. But at this point, do a little red line there. At this point, we are in pre-calculus territory. Knowing that that's related to continuity is arguably calculus territory, not really. But anyway, solving this equation is definitely pre-calc stuff, and it's that prerequisite that we really need to solidify. Anytime I have something fancier than an x, whether it's a 3 times x or an x plus pi or whatever, anything fancier than an x, my recommendation, my strong recommendation, again, based on many years of experience, is to replace it with a smiley face. And a reminder that for this problem, unlike the first one we did in notes, for this one, I am restricting us to 0 to 2 pi, and yet I'm still using the smiley face, and we will talk about why in just a minute. So once I've got just this fairly simple cosine of junk equals 0, I'm going to draw a picture of the unit circle, and I'm just going to mark the spots where cosine of that angle would be 0. And so there are 2 spots, but that does not mean that there are only 2 solutions. So something I saw a lot of you doing on the prereq is you would say, oh, so either 3x equals pi over 2 for the top, or 3x equals 3 pi over 2 for the bottom, and then you solved that, and you got 2 solutions, but we're going to see in a few minutes that there are actually 6 solutions. So instead of just naming those 2 spots the normal names, we're going to name all of them all at once. There are infinitely many smiley faces, and then we'll figure out the x's, and then we'll figure out the 0 to 2 pi. So as we've seen, I'm just going to pick one of these, and I'm going to call it something that I could. So I'm going to choose to call that pi over 2, because that's what a normal person would call it. Technically, I guess that's what, 5 pi over 2? You could, but that's weird. And so what we're going to do, we've dealt with the cosine by drawing the picture. I have chosen to start at pi over 2. I could have chosen to start at 3 pi over 2 there at the bottom. Or I could have started at the bottom and called it negative pi over 2. It doesn't matter, because in the end, we're still going to get all of the same answers. Then, I'm going to figure out how far it is from the spot that I started to the next spot. So to get halfway around the unit circle, to get from pi over 2 to 3 pi over 2, I have to move pi units. And so that's kind of your step distance, some people call it that, but just the distance to the next solution. But then remember, I could add pi once, but if I added it twice, I would still get to a good point. If I added it 3 times, or 4 times, or so on and so on. And so that's why we do that n at the end. It represents an integer, a whole number, and positives and negatives, to tell me how many steps I want to take. So if I want to add pi 37 times, well then n equals 37. And this idea of a starting point, distance to the next guy, and then the number of steps, that's going to help us at the end here. This has been the trig part. We took care of the cosine, and we found infinitely many solutions for smiley face. I know I haven't forgotten about this 0 to 2 pi, but it doesn't matter right now. We're going to come back to that. So we've taken care of the trig, and so I'm going to go back and replace this smiley face with what it was standing in for, which was the 3x. The smiley face just allows my brain to focus on the trig before we start dealing with that 3 that's causing trouble. And so now, this is an algebra problem, but a pretty straightforward one. I'm going to divide everything by 3. So my x is pi over 2 over 3, that's pi over 6. And then for this second pair, I could write pi n over 3, that is correct. But to kind of keep the same pattern going as what we saw above, I like to leave that n off by itself. Something else that I tend to do at this step, and you'll see why in just a minute, is I'm going to go ahead and get a common denominator. So that pi over 3n, I'm going to rewrite that as 2 pi over 6n, just so both of those terms have a common denominator. So we have found infinitely many solutions, and that's important because that ensures that we're not going to miss any that are in 0 to 2 pi. But we don't want our final answer to be all of them. We have to figure out who is in that interval, 0 to 2 pi. So this is where that's going to play a role. And that pattern of a starting point and taking steps is going to be helpful. Because what I have in pink tells me that pi over 6 is a solution. It is a starting point. It is one discontinuity. It's a bad x. It's an excluded value, whatever. And then what this other thing tells me I can do, and why I recommended getting that common denominator and leaving the n off by itself, that tells me that if I add 2 pi over 6, I'm going to get another solution. And by having the common denominator, that's really easy to do. And you can reduce that to pi over 2, but you don't need to. And I can add 2 pi over 6 again, and get 5 pi over 6. And I can do it again, 7 pi over 6. And I can do it again, and I'm not going to do this forever. I am going to go off the board a little bit. 11 pi over 6. Add another 2 pi over 6. 13 pi over 6. And like I said, I'm not doing it forever. I'm doing it until I get past 2 pi. 11 pi over 6 is smaller than 2 pi, so that's good. 13 pi over 6 is too big. That is bigger than 2 pi. That is out of my interval. The other thing that you should just generally check, because it kind of depends on some of the choices you made with that smiley face thing early on, I'm also going to subtract 2 pi over 6 until I get an answer that's too small. And in this case, that just takes one step. Negative pi over 6 is outside of my interval because it's less than 0. But once again, what we've done here the way this answer, not an answer yet, but the way this expression is set up, gives me a starting point. And depending on choices you made earlier, you might be starting at pi over 6 like me, or maybe you started at 5 pi over 6, or maybe you started at pi over 2. But by starting wherever this tells you to, and then moving forward by that step amount, and also moving backward just in case, and then just list everything that fits between 0 and 2 pi. And so as I said earlier, there are not just two discontinuities here. There are not just two solutions to this equation that we've been dealing with, cosine of 3x equals 0. There are two spots on the unit circle where smiley face might be. That's true. But by doing the additional work, we have found a total of 6 solutions. And that is quite simply because the 3, as I mentioned earlier, gives me 3 times as many solutions. And so in terms of prereq stuff, I'll do another line. That's the end of a question you would have done in pre-calculus. That's clearly the harder part here. But what we have now is 6 discontinuities, and so we're ready to answer that continuity question. So the actual calculus part here. So my function is continuous. I could write the intervals, but good Lord, that's going to be a lot of intervals. So I'm just going to say we're continuous everywhere except at those 6. Pi over 6, 3 pi over 6, you don't have to reduce it. 5 pi over 6, 7 pi over 6, 9 pi over 6, and 11 pi over 6. We are continuous everywhere else. That's an okay way to talk about continuity as well. And then we have to decide whether those x values, or those x coordinates, give us removable or non-removable discontinuities. And once again, I'm going to go back to the very beginning, because if you remember what the secant graph looks like, just the basic secant graph, you might remember that that's another one that has vertical asymptotes, and it has some upward pointing u's and some downward. And so if you remember that it has vertical asymptotes but no holes, then that's one way to know that these are non-removable discontinuities, just knowing the graph. The other option is to say, well, we just made the denominator 0. We just found the spots where the denominator is 0, and clearly the numerator isn't going to be 0 ever. And so because of that, since I have a non-0 over 0, that is what causes the vertical asymptote on the graph. And that's also another way to know that we have a non-removable discontinuity at each of those points. Even if you didn't remember the graph had vertical asymptotes, just looking at that expression or at the function, a non-zero on top, but these 6 numbers give me a 0 on the bottom. Therefore, I have a vertical asymptote. Therefore, it's a non-removable discontinuity. So I'm going to scroll out a little bit so you can see it all at once if you want to. This skill, especially between those 2 red squiggles, that skill is something we need to practice. It was on the prereq. You're going to see it on homework. We're going to see it again and again. So use this video, use the smiley face, and go with it that way. I mentioned there's some other ways to deal with the 3x other than the smiley face. If you're interested in those, come to office hours and ask. But this, again, just based on my experience as a student and definitely as a teacher, this one seems to work the best for the most people. But if you want another option, come and talk to me and I'll show you one. So that does it for me.